Good morning, friends. It is my privilege to introduce Dr. C S Yajnik. He is the professor and director of Diabetic Unit Consultant, King Edward's Memorial Hospital and Research Center in Pune. He has the area of interest, the high susceptibility of diabetes in Indians, intrauterine programming of diabetes, vitamin B12 and 1C metabolism, hallmark merit award of the International Diabetes Federation in 2009, David Walker Medal of the International Dual Society 2011, and Outstanding Investigator and World India Diabetes Foundation 2016. And 41 Gopalan Oration Award, Nutrition Society of India 2017-2018, and March of Dims Higgins Award in 2019. And for international ranking, top 0.4% diabetes endo nutrition, and have lot of publication like total 303 publications, first author of 79 and research articles 150 and review article 56, and book chapters of 6 and other 87. So he is a very wonderful speaker from to you. So please, Dr. Yajnik.
Thank you, Chairman, and good morning, everyone. Maybe I'll exceed the time a little bit. I'm going to talk about an intergenerational B12 story based on our research, but initially going to introduce some of the common things about B12. First, I have to say B12 is a very unusual vitamin. It's the only nutrient on which 5 Nobel Prizes have been won. So it's very unusual in that sense. It reacts, or it actually is a cofactor for 2 enzymes. One is the methionine synthase, where along with folate, it allows homocysteine to be methylated to methionine. And as you know, methionine is the initiator sort of codon and the first amino acid for all the proteins. And this cycle also provides methylation for the DNA and RNA synthesis. So profound actions. The other enzyme it acts on is the methylmalonyl-CoA mutase, and that allows mitochondria to receive the fatty acids and the other amino acids for the TCA cycle. So it has profound effects on the metabolism through methylation, through generation of methionine, and through energy metabolism. And that is how actually it has wide actions in the metabolism. Again, to say like DNA RNA synthesis, energy metabolism, lipids, messenger substances, and detoxification of certain either exogenous or endogenous products. Interestingly, there is very high prevalence of B12 deficiency in Indians. Partly it may be genetic, like most of the things, socio-cultural practice of vegetarianism, and poor socioeconomic status. We'll see how. B12 supplementation, therefore, now has become a very common practice in India. And all the preparations which are available on market, including the lowest one like Neurobion Forte, are much higher than the recommended dietary allowance, which is only 2 to 3. And for all these years, ICMR had only 1 microgram as a RDA for all this thing. So that is something we have to be aware of. The B12 cycle is that it actually comes from diet, but ultimately from animal origin foods. Then it goes into the sort of system. It has a very complex mechanism of absorption, and whatever is not absorbed in the terminal ileum is delivered to the colon. And the colonic bacteria actually thrive on vitamin B12. There are different types of bacteria, some which can make B12, others which utilize B12. And the gut dysbiosis or symbiosis is actually driven by this. The bacteria not only utilize it, but they produce analogs which may not be similar to the analogs which are produced in the usual human metabolism. And this is a hot topic of research. We are not going to get into it, but it has been implicated in a whole lot of diseases like Alzheimer's, some cancers, and other neurological disorders. and therefore microbiome and B12 is now a focus of research and attention, and that's why I called it the elephant in the room. We are just now involved. I don't have many results to show, but in some time we will have it. It's also interesting that these two vitamins act on the same enzyme and therefore have very similar actions ultimately. And interestingly, folate is all vegetarian origin, therefore this side of the figure I have written it in green color, and vitamin B12 folate's pink color. So this is vegetable origin, this is microbial origin. Non-vegetarians are more likely to have folate deficiency. Folic acid or folate are affected by cooking. B12 is not affected by cooking. Recommended doses for B12 are much lower than folate. Folate is absorbed very liberally, and absorption of B12 is extremely tightly regulated, as you will remember from your physiology studies. There is a safe upper limit given for folate, 1 milligram in Europe. For B12, we really don't know. Deficiency of folate leads to increased homocysteine. B12 deficiency leads to higher homocysteine as well as MMA, and MMA is specific for B12 deficiency because mutase enzyme is regulated only by B12. And in clinical use, we use either folic acid or folinic acid, and for B12, we have cyanocobalamin and methylcobalamin as common agents. Again, folic acid is not folate similar. Folic acid is synthetic, it's a pteroyl monoglutamate, and it's oxidized state. So to be metabolized in the body, it needs to be reduced by liver enzymes, and if you have polymorphisms in these enzymes, you don't metabolize folic acid to further active metabolites, so folic acid might accumulate. It's highly bioavailable compared to the natural folate, and there is actually a suspicion that high dose or high circulating levels of folic acid either might produce an excess effect and sometimes might inhibit the natural folate action on the cells, and therefore high folate or high folic acid in circulation is not a good thing. I got introduced to all this when Helga Refsum from Bergen visited Pune as a Rotary Exchange Fellow in 1993. And she came and asked me, do you know about homocysteine in Indians? I had heard the word homocysteine, never measured it in 1993. And she offered to measure it in our samples. And in the first study, we found that a large number of people in my diabetic clinic, 77%, were high homocysteine, hyperhomocysteinemic. And unlike the expectation from the papers up till that time, instead of folate deficiency, it was driven by B12 deficiency. It took us 6 years to publish this paper because people just wouldn't believe us. Then I did a community-based study in rural Pune, urban slums and urban middle class, and you will find rural and urban slum people only about 50% had hyperhomocysteinemia or B12 deficiency, while in the urban middle class almost 80% had low B12. And this we linked with probably safe water supply through piped water to the urban class, while the slum people were probably drinking contaminated water. And this was the original theory given by Professor Mathan and Baker from Vellore, that if a village near Vellore, where they studied it, if people drank 1.8 liters of water, it was contaminated by bacteria enough so that they will not have B12 deficiency. So we indirectly showed that in a subsequent study, and therefore hygiene of water and surroundings is one of the important source of B12 for people who are living out in the field. What are the common causes of B12 deficiency? I contributed to this review in Nature primer with very big people actually, and we wrote different things, showed the elaborate mechanism of absorption, which we are not going to go into detail, But because of me, I think they were able to say that pernicious anemia is very rare in majority of countries where actually B12 deficiency exists. Otherwise, when we were students, we were taught B12 deficiency, megaloblastic anemia, pernicious anemia. And we just assumed. Now I know it's a nutrient deficiency due to low dietary intake, predominantly because of vegan and vegetarian sort of cultural practices, and low socioeconomic status if it doesn't allow you to eat animal origin foods. They might have other nutritional deficiencies, like in India we have a lot of iron deficiency along with that, and the severity of that is obviously less than in pernicious anemia. Interestingly, small oral doses of B12 might be effective in these cases. And we proved this in an absorption study in over 300 people, where we used a dose of 10 micrograms into 3 by using a Danish protocol, and showed that absorption was very good in more than 90% of our village population. Then I used 2 microgram dose to again show that absorption was quite good, and therefore we were quite convinced that actually we can use long-term small doses to treat B12 deficiency. Also now the problem in the literature is that majority of studies are cross-sectional, observational, and in adults. Therefore we are looking at end-stage conditions. Causality is difficult to ascertain, and therefore prospective studies from early life are really interesting. And that is called DOHAD, or Developmental Origins of Health and Disease. That also tells you about intergenerational effects, and then you can use clever models like Mendelian randomization and finally intervention to prove your findings and causality. And I think I have tried to do that over the last 25 years. So this has been a focus of our attention in my department: micronutrients, fetal growth, and risk of non-communicable disease in a developmental origin model. And this is the developmental origin model, that you start with mother or a grandmother and go through her nutrition, metabolic, and other studies that affects the epigenome of the baby, causes differences in fetal growth, development, and differentiation. That can be detected in birth phenotype simply as either low birth weight or high birth weight, but more detailed measurements can tell you many more things, and then follow them up through the rest of the life. And in my department, I'm not going to boast much about this, but we have done a number of studies and cohorts over the last 30 years, which have now involved B12 studies since my introduction to Helga Repsum. We were the ones to do the largest study of neural tube defects in India. 4 centers: Pune, Hyderabad, Ahmedabad, and Chennai. And what we found was that we studied actually more than, I'm actually jumping one slide. So this was the original NTD prevention trials, for which actually now the folic acid has been popularized. So there was a study of recurrent neural tube defect prevention driven by MRC in UK. The dose was 4 milligrams of folic acid. This is the recurrent neural tube defect. That means mother had history of previous neural defect pregnancies. And they showed that 4 milligram folic acid started preconceptionally, prevented or reduced the risk of neural tube defects. The first occurrence of NTD prevention trial was in Hungary. And it's interesting to know, people completely forget about this, that trial also provided 4 micrograms of B12 to these women in addition to 0.8 milligrams of folic acid. And in the intervention group, there were no neural tube defects at all compared to small number in the other group. We did a study of neural tube defects in India, as I said, in 4 centers, and we had more than 300 neural tube defects enrolled. And what we showed was folate was no different. Maybe some of them were already taking folic acid or IFA tablets, but homocysteine was higher in the mothers whose babies had NTD, and the holo TC, which is the active B12, was lower. Then referees asked us to prove this by a genetic measurement. That's where I said you can use Mendelian randomization or genetics to prove causality, and we did genetics and found the usually suspected enzyme like MTHFR was not really contributing much. It was mainly increased through TCN2, which is transcobalamin 2, which is the active transporter of the B12. And this actually has been published now more than 10 years ago. This is the famous Pune maternal nutrition study. I'm saying famous because I talk about it everywhere, and where we studied more than 2,500 women in 6 villages, 814 pregnancies, babies were born, they were measured every 6 months for growth for 18 years, and now we measure them every year. Every 6 years we measure the families, and now we are into 24-year follow-up. Extensive information is available, and we have a very enviable biobank of samples starting from beginning. And mothers were 42 kg to begin pregnancy, and babies were 2.7 kg. Concentrate on the last line. Gestational diabetes in these days was very uncommon. 2 out of 3 mothers were B12 deficient, and out of 800, only 2 women had low folate status. And the babies which were born were actually proved to be thin fat. I'm not going to talk about that today. So that these babies, though they were 800 grams lighter than the English babies, they had more fat. And interestingly, circulating folate and homocysteine concentrations were determinants of their birth size, and high homocysteine, which predicted small for gestational age, came largely from B12 deficiency. We followed up the children, as I said, and we have shown in series of studies that low B12 and high folate in the mother predicts higher risk of diabetes in the baby by driving higher adiposity and higher insulin resistance. And we have now fantastic studies through a fellow, India Alliance fellow, showing that different parts of brain development are demonstrable by MRI functional as well as structural in these children. This is where I think the discussion was there just now. In India, we are vegetarian for more than 2,500 years ago, since days of Samrat Ashok. When he became disciple of Buddha, he introduced ahimsa. These religions, especially Jain, Hindu and Buddha, promote vegetarianism, and as I showed you, higher education, better income and better hygiene may be a risk factor for B12 deficiency. Folate is usually adequate unless you are very poor. Higher socioeconomic status, better folate status. The National Anemia Prophylaxis Program, now whatever we call it, Iron Plus, etc., provides iron and folic acid. And as it was mentioned, obstetricians use tablet called Folvite, which is 5 milligrams, which is 12 times higher than the 400 microgram dose, which is now prescribed for prevention of neural tube defect. And many of the obstetricians use 2 or 3 tablets a day because they think it is entirely harmless. So we studied B12 deficiency in a life course model in PMNS, and actually all this information which is there on this slide was collected starting with genetics, maternal transfer, whole lot of growth, absorption we has measured, family environment, diet, activity, socioeconomic status, and now we are adding microbiota. Interestingly, the B12 concentration in these children started at a level of about 250 at 6 years of age when we first measured it. By 12 years, they have dropped to about 200, and by 18 years of age, they have dropped to about below 150. 150 is the cut point for deficiency. At 18 years, 58% were deficient. Their folate status was actually quite good. Only these numbers were deficient, less than 5%. And homocysteine, amazingly, at 17 years, 90% had hyperhomocysteinemia. And their hemoglobin, MCV and TLC showed it. We have done a GWAS, maybe I'll need 5-10 minutes more, sorry. We did a GWAS to find out what are the genetic determinants, and what we found was we confirmed the international determinants, and interestingly there was an additional polymorphism in the FUT genes which look specific for Indians. We also showed that maternal to fetal transfer occurs across placenta and that it persists to have association with the offspring B12 right up to 18 years of age. So whatever baby is receiving from mother seems to actually influence long-term B12 status. And therefore this multivariate model showed that genetics, family environment, rapid growth, poor nutrition of milk and non-vegetarian, and better hygiene are risk factors for B12 deficiency. And therefore we have developed this model which came in the Nature paper. It's important to have good B12 status preconceptionally and periconceptionally, because both the sperm and the ovum development and the early embryo development are affected. We then set up a low dose B12 trial in the cohort, giving only 2 micrograms per day when these girls and boys were 17-year-old. It has gone on for last 8.5 years. And in 8.5 years, we have delivered 200 of these girls so that we have third generation information. And what we showed was those girls who were excluded from the trial because they had very low B12 and it was a placebo controlled trial, you can't continue them. So we gave them 2 micrograms per day. And with the 2 micrograms per day, in those who had B12 less than 100, their B12 improved, their homocysteine fell, their hemoglobin improved, their MCV came down. So in a way, this is a public health message. This may not be true in clinics.
Professor Yajnik, time over, please.
Yeah, 2 minutes. So therefore, you can use small dose. And in the trial, when the children became 2-year-old, we performed their neurocognitive tests and we showed that their brain function is better. We have done extensive molecular studies to show that B12 affects methylation, including of genes of diabetes and the transcriptome of the cord blood. There is a collaboration with Oslo where we showed placental leptin gene methylation is different in South Asians compared to the Europeans. That probably links with my thin fat story. That's how they approached me to actually guide this study. I guided this PhD there. And finally, I'm going to tell you a new story which has excited me. Give me 2 minutes for that. That these FUT genes are what is called secretor genes. And these PhD student of mine, Pooja, and postdoc Krishna have done this work. Secretor status is body's ability to secrete the blood group antigens into body fluids. So you are either secretor positive or secretor negative. That means you can detect the antigen in your saliva or any other body fluids which you care to take. And recently we have done this extensive analysis because we have such data available with us. In addition to showing association with B12, which was the original GWAS finding, we have now shown association with a whole lot of things like glucose, HbA1c, H. pylori infection, CRP. And because we have other cohorts of type 1 and type 2 diabetes, we have been able to show that secretor status is associated with type 1 diabetes susceptibility and a subtype of type 2 diabetes. I am actually very excited about this, that this is something new and we are going to learn more and more about it. Finally, this secretor status was reported as a factor increasing severity of COVID infection. It has been published from, this is from UK Biobank in UK, and an Indian, Tanvi Rahaluwalia from this city, published a paper from Copenhagen which showed that FUT2 is also linked with childhood asthma and streptococcus pneumoniae infections. So I am actually very interested in this model that vitamin B12, secretor status, host genotype and gut microbiome are interacting in various ways to increase susceptibility of different risk factors to diabetes and related disorders. Finally, while attending a meeting in Paris almost 15 years ago, in a side alley, I found this shop. The shop was called B12, and what it sells is actually clothes for men. So in other words, I think they are saying that body composition of men, which is more muscular, might be driven by B12. So that was a very funny incident. Thank you.
Thank you, Professor Yajnik, and congratulations for a wonderful talk. You have talked regarding the deficiency of the B12. What about the excess of the B12? So many times patients have neuropathic symptoms and or asymptomatic, but you go for the levels of the B12, Matthew Gowal, the value is more than 2000. So what are any toxic levels or any sign and symptom of the toxicity of the B12?
Thank you for asking this question. I was reading this. Yeah. Okay. So one is the assays of B12 which we use today are rapidly becoming unpopular, even though you use the advanced systems. 3 advanced systems which are available in the world, each gives very different results.
Okay.
High B12 levels can occur pathologically, that is naturally, in certain liver diseases, in certain cancers, and some granulomatous disorders. But the commonest cause of high B12 is overtreatment.
Overtreatment, definitely.
And many times people don't know that they have been prescribed B12 because GPs would just prescribe high dose B12s. I call this as a success of your own, or your victim of your own success sort of phenomenon. Okay, after I started this movement in Pune, the laboratories are now reported values above 1000 every now and then, and which is what Dr. Wangnu was also saying. So part of it is iatrogenic, part of it may be disorders. Okay. And the assays are a problem. There is a lot of international movement to improve the assays.
Okay. Thank you, sir. Thank you. Please, sir.
I'm Dr. Satish Chugh. I think House is impressed by your commitment to B12 and folate. My question is that, as you have already told, that we only get mostly from vegetable, this animal origin B12, and we also know that animals themselves, they don't make this B12. This is some sort of a group of microbiota which creates B12 in them. So in this era of bioengineering, have you ever thought of collaborating with someone to produce those bacteria which can be dispensed in very small amounts to make a good level of B12 and to prevent homocysteine in many of us?
Very good question. Thank you. Currently, I am having a big grant with BBSRC and University of Kent and Cambridge to investigate algal sources of B12, because algae live in symbiosis with bacteria which make B12. And we have already done a pilot study of an algae called chlorella, and we have shown in pilot trial that it improves your B12 status. The University of Kent has also given their E. coli model, which is they call super producer of B12, for synthesis of B12 within India at a lower cost. So it will be available at a lower cost. And third thing, people are thinking of various probiotics, and I tested one probiotic which is Propionibacterium, which was given to us by NDRI, the National Dairy Research Institute in Karnataka. And that, unfortunately, in our trial did not increase B12 levels or decrease homocysteine. But I am sure there are bacteria which we could use.
Thank you.
Sir, it can be, it should be given with the metformin, B12, with each and every case, because it
Sir,
causes
I didn't get your question.
It should be given with the metformin, B12.
Should be given
The combination of the metformin.
metformin. Yeah, again, like say you could give small dose, and as I said, the smallest dose is 15 micrograms like Neurobion Fort, but I see people starting 1500 microgram B12 tablets along with metformin because of the reports that metformin deficiency will produce B12 deficiency. as it is, the levels are low in our people, so people should have low dose supplement. There's probably no need to add more B12 than the usual small doses.
Small dose. To each and every patient.
Sorry?
To each and every patient you should give.
Yeah, I mean, if
Yeah, only deficient
80% of
patients.
urban middle class has B12 deficiency in Pune, that is likely to reflect in higher deficiency across the country. There are, I know, pockets in country where there is no B12 deficiency. Like I contributed to a study in one of the Kerala villages. There was no B12 deficiency there.
One or two company came with the combination with the
Yes, but
metformin.
as
with
a
the
public policy, it's easier to give it to everyone in small dose, and that's why I did the 2 microgram dose trial.
Actually, it takes 3 to 4 years to develop this vitamin D B12 decline when you are giving metformin.
Yeah.
In the long run, they develop because of 2 reasons. One is more often than not, about 50% of diabetics, they develop achlorhydria as a result of frequent use of PPI.
Yeah.
So the intrinsic factor is deficient there. Second is metformin causing problem at the terminal ileum where the absorption of B12 is affected. So you must supplement vitamin B12 so to prevent cognitive dysfunction also may take place in them.
Right.
Thank you so much. We are running short of time. So I
Okay,
must
thank you for the
congratulate
extra time. Thanks.